Welcome to Institute of Quality and Reliability. Hi, this is Hemant.
Sigma level and PPM. In this video, we will explain who created the concept of Sigma level and a Six Sigma approach. Then we will discuss the definition of Sigma level and the concept of 1.5 Sigma shift as explained by Motorola. We will then illustrate how to estimate proportion defective and PPM level on Microsoft Excel at various Sigma levels. We will also plot a graph of Sigma level versus PPM. Sigma level, how it all started. The concept of Sigma level and the Six Sigma approach was created by Bill Smith, who is known as the father of Six Sigma. He was working for Motorola during the late 1980s when he suggested this Six Sigma approach. It is also believed that Michael Harry and others also contributed greatly to create the methodology and toolkit of Six Sigma approach. Six Sigma approach encompasses the best tools, but we must also understand and appreciate the reality that the tools deployed in Six Sigma approach and roadmap have been created during the past more than 100 years by many quality gurus as shown in the figure below. Not all are shown here, and there could be more also who contributed to the development of all these tools. The proportion defective at various sigma levels is estimated using normal distribution. Therefore, it is essential to understand areas under a normal distribution to perform these calculations. You may like to watch our video on the normal distribution. Link to this video is provided in the description of this video. Let us understand what exactly is sigma level. Sigma level relates to quality performance of a process, and we can estimate proportion defective or PPM if we know sigma level of a process. And we are going to illustrate this procedure using Microsoft Excel in this video. If tolerance equals 2k sigma, k can be considered as sigma level of the process, sigma being the standard deviation of the process. So, for sigma level of 6, k is equal to 6 and therefore tolerance is equal to 2 into 6 sigma, that is 12 sigma. Similarly, for sigma level of 5, k is equal to 5 and tolerance equals 10 sigma. Or for sigma level of 4, k is equal to 4, therefore tolerance will be equal to 8 sigma, and so on. The table shows this. This sounds interesting, but how does the sigma level relate to the percent defective or PPM levels? Let us now understand the conceptual basis for the calculation of the Six Sigma metric. According to research and observations at Motorola, process mean tends to shift to the extent of 1.5 sigma in the long term with increased chances of defects. Proportion defective is estimated considering this 1.5 sigma shift in the process mean. The animation shows this shift of process mean. This shift could be a result of tool wear, environmental changes, drifts, material changes, machinery condition changes, people changes, etc. We will now explain how the percent defective or PPM level can be estimated using Microsoft Excel. Let us perform the calculations of proportion defective for various sigma levels on Microsoft Excel. We will consider mean shift of 1.5 sigma for this calculation. First, let us do this calculation for 12 sigma level of performance. We will consider that the process mean shifts to the right by 1.5 standard deviations. However, the calculations will be similar even if the process shifts to the left by the same amount. Before shift, the distance between mean and USL, that is upper specification limit, is 6 standard deviations, 6 sigma. After shift of 1.5 sigma, the distance between the new mean and the USL will be 6 minus 1.5 or 4.5 sigma. Let us perform the calculations of the proportion, defective and the PPM levels on Microsoft Excel. We will use the logic that we have discussed so far. In the first column in the table created in Excel, I am writing sigma level, and the first row shows 6 because first we want to calculate this proportion defective at sigma level of 6. Distance of mean to USL without shift is 6 sigma. Distance of mean to USL after 1.5 sigma shift is 1.5 sigma less, that is 4.5 sigma. Now to calculate the proportion defective to the right of USL, I will use the function normDist. For using the function normDist, I go to the cell and click on FX. In the functions, I choose statistical or all. In the functions listed, type N so that you can see the function norm.dist. I click OK. It has 4 arguments, X, and what is the X? X is equal to USL, which equals 6 sigma. So I choose 6. Mean is equal to how much? 1.5, because the mean has shifted to 1.5 sigma. The standard deviation is 1 and cumulative is again 1. I will say OK. And I see proportion defective to the right of USL as 0.99. But remember, this function norm.dist always gives the area under normal distribution to the left of the X value. Since we selected USL as X, this is area to the left of USL. But the proportion defective that we want to find out is to the right. So we subtract this value from 1. So that means it is 1 minus this norm.dist function. And I get a value of 0.5 times 0.34. Similarly, I can also calculate proportion defective to the left of LSL. Again, I use the same function, but now since I am looking at the left side value, I can use the norm.dist directly. So I'll type in norm.dist, norm.dist. Now X is minus 6 here because the LSL is to the left of mean. The original mean is 0, but the shifted mean is 1.5. That is the mean. Standard deviation is 1 and cumulative again is 1 or 2. So that gives me a value of 3.2 into 10 raised to minus 14, which is a very small value, actually negligible, because it is 7.5 sigmas to the left of the new mean. So the total proportion defective will be sum of the two columns, these two columns, and I write a formula equal to sum of these two columns, and I get a value of 0.5 times 0.34, which is almost the same as column D. If you want to calculate the PPM, you will have to multiply the total proportion defective by 10 raised to 6. So I write down equal to the total proportion defective star, and 10 raised to 6 means 6 zeros after 1. So that gives me 3.4 ppm. So we can conclude from the first row of calculations that the ppm level corresponding to 6 sigma level of performance is 3.4. Now let us perform similar calculation of proportion defective and ppm level for a 5 sigma process. So in the sigma level I have entered 5. Distance of mean to USL will obviously be 5 sigma. Distance of mean to USL after 1.5 sigma shift will be 3.5 sigma. Proportion defective to the right of USL, I can just copy this formula and paste it into this cell to get the proportion defective as 0.402326. Proportion defective to the left of USL, I can copy the formula, but I may need to modify that because instead of -6, now I must write there as -5. Still, the proportion defective to the left of LSL is very small. I can copy the formula in the remaining two columns. So now the proportion defective total is 0.402326, almost the same as defective to the right of USL. And the ppm level is now 232.63. We can round it off to 233. So for a 5 sigma process, the ppm level is 233. If we perform similar calculation for a 4 sigma level of process, we get total ppm level of 6210, and for a 3 sigma level of process, we get 66811 ppm. We can further add interim sigma levels such as 5.5, 4.5 and 3.5 and again perform the calculations for all these levels. The last column of ppm shows how the ppm level increases as we go from 6 to 3 sigma level. We can plot a graph also. So I select the sigma level column and press Ctrl button and select the ppm and then say insert recommended charts, and I can plot a chart like this. And I can also add the axis labels and simplify the x-axis. So first I select this chart. So I have selected this chart. I can modify the x-axis scale to, let us say, from 3 to 6 instead of 1 to 7. So I'll say format axis. Minimum is, let us say, 3 and maximum is 6. And I have changed the scale. We can easily add axis titles, increase the font size and choose the chart design that we prefer. After that, the chart will look like this. So this is the chart of sigma level versus ppm level. Table of sigma level versus defects per million opportunities DPMO can be downloaded from the downloads section of our website www.world-class-quality.com. The link is shown in the description of this video. This table shows DPMO instead of ppm. ppm is actually a specific case of defect level when we classify parts as defective or not. In 6 sigma, sometimes DPMO is used instead of ppm when there are more than one opportunities for defect. Let us do a quick recap. In this video, we have seen who created the concept of sigma level and the 6 sigma approach. We have also seen the definition of sigma level and concept of 1.5 sigma shift as defined by Motorola. We have illustrated how to estimate proportion defective and ppm level for various sigma levels. We have also plotted a graph of sigma level versus ppm. Thanks for watching this video. Hope you found it worth watching. Please subscribe to Institute of Quality and Reliability channel if you want to watch more videos on reliability engineering, Six Sigma and quality engineering.